Hello student, myself Devangsha. Let's start with the basic course of basic electrical engineering having the subject code of 3110005. Uh, it has a teaching scheme of 3 hours of lectures and 2 hours of practical having a 4 credit in university. So we live in a wired world. So as you can see here, there are some home appliances including microwave oven, television, washing machine. In all the equipments, the basic component we use as a electric circuit. So ultimately, because of this electric circuit, all are getting the energy where all the appliances are going to be run, where the electrical energy is converted into a mechanical energy. So in short, broadly speaking, we have to construct this electric circuit to utilize those kind of home appliances. So here the basic terms of uh, resistance, inductor and capacitor. So here you can see, uh, broadly speaking, we divide this basic electrical engineering into two parts. One is called the DC circuits and another one is called the AC circuits. In DC circuit, you have to apply the DC voltage where the direction of current is in a unidirectional. Same way in a AC circuit, the direction of current in a bidirectional, right? Now these are the basic electrical components where having the resistance, inductor and capacitor. You can see the symbol here, where we need to understand how we are going to use this resistance, inductor and capacitor. So ultimately we have to check the behavior once we connect all this resistance, inductor and capacitor in a circuit diagram. So here you can see the series and parallel resistor circuits, where the dots is the nothing but the movement of the current, where in series and parallel combination you will find the total resistance. In series it's a addition, in a parallel it's a reciprocal in terms of the resistance. Now again, once you know use those kind of RLC, one step ahead you have to follow a different uh, circuit laws like Ohm's law and Kirchhoff law. So you can see here the triangle of Ohm's law that contains the V is equal to I into R. So basically in this particular video you can see the relation of resistance, voltage and current with respect to Ohm's law, where you can also furthermore include the movement of currents as well as the voltage drop across resistance using the Kirchhoff laws. Now, once you define any complex circuit or you design any complex circuit, some of the basic shapes you can see like star and delta transformation, and most of the complex circuit you can solve using Thevenin's theorem, Norton's theorems, superposition theorem, source transformation theorem. So these are nothing but a kind of network theorem. So ultimately we have to use those kind of theorems and transformation to solve a complete network. So these are nothing but a one kind of circuit methods. Now the next topic is charging and discharging of capacitor and inductor. Once this capacitor and inductor both are in excitation of the DC supply, see you can find once the capacitor is charging or inductor is charging, you can see here the video how the accumulation of charge is possible in capacitor and inductor. Now in our second unit we are going to understand about the AC circuits, where how the alternating EMF of single phase is being produced between two magnets. So this is how the coil is moving from 0 angle up to 360 angle, and that will generate alternating current. Now broadly speaking, uh, again our basic components are resistance, inductor and capacitor. Now they are under excitation of AC signal. Now it's AC signals. Ultimately this parameter is it's a one kind of vector parameter where the direction and magnitude both are very important. So again we are going to find a behavior of resistance, inductor and capacitor with terms of the AC signal. Same way now we are using the combination of RC, RL, RLC with the series combination as well as parallel combination. How they all these components in combinedly they are going to behave under the application of AC signal. Same way here at resonance condition is condition where is a specific frequency, how this resistance inductor capacitor in series, how this resistor inductor and capacitor are parallel are behaving. So that frequency response you need to see. Now same way here in a three-phase AC circuit, same way in a single phase, there is only one winding. Here the three windings are connected 120 degree apart with each other. So you got to understand how the three phase within a same assembly can be generated. Now all this circuit, once you design, you need to check the circuit efficiency, and that circuit efficiency you can always find with the calculation of power factor. So ultimately power factor is nothing but the will give you the relationship of voltage and current of any AC circuit. Same way in our unit 3 we can learn about the transformer, which is made up of the magnetic material and having the characteristics of BH curve. So ultimately using those magnetic materials you can design more specific magnetic circuits, and that will give you operation of transformer where the your signal is being transferred from one level of AC signal to the another level of AC signal. Let's see this. Now in this particular video you can see here, there is a primary winding, there is a secondary winding. Where you apply the current, there is a induction of magnetic flux, and that will follow the Faraday's law of electromagnetic induction, where you apply the input AC signal, and at the output either you will have a step up voltage or step down voltage. So based on this you can see here this kind of terminologies or types of transformer are called step up transformer and step down transformer. So we are going to learn in our next videos as well. Same way, once the transformer is being constructed, once you learn the operating principle of this transformer, you can also check the ideal condition of transformer as well as the practical condition of transformer. So in our real world we are going to use a practical transformer where you have to also incur the losses occurred during the operation of this transformer. Same way, like we already talked about the single phase AC circuit. Now the three phase AC circuit, same way the construction of single phase transformer as well as the three phase transformer is also possible. So within a same assembly, if you are going to use three windings like R, Y and B of each and every limb of the transformer, you can also construct the three phase transformer. So now in widely in industrial application we are using those kind of transformers. Yeah. Next, this is a single transformer. We can say a kind of single device where within a with one winding we use as a primary winding as well as the secondary winding. So within a one device you will have both the features of a kind of primary winding as well as secondary winding. So within a one device you can generate step up and step down transformer itself. Now in our next unit you can see this is an electric machine. So ultimately machines that's going to convert one form of energy into another form of energy. So in this machines here we are going to convert electrical energy into mechanical energy and vice versa. So we are also going to convert mechanical energy into electrical energy. So you can see here the kind of induction motor. One is the single phase induction motor and another one is a three phase induction motor, where some basic parts we are going to learn, like what's the job of rotor, how the stator winding is being built, and how the stator is also going to be function in this particular term. So you can see in this particular video there is a generation of rotating magnetic field, and because of this we are going to convert this complete terminology or electrical signal into a mechanical signal. Now in application we are using this motor in our home appliances like microwave, washing machine, in our fan system, in our TV, refrigerator, everywhere we are going to use this kind of electrical appliances where the motor is a basic instrument. Now in this particular term you can see this is a DC motor is going to convert again the electrical energy into a mechanical energy. So ultimately this generation of this electrical energy here, it's AC. Now somehow I have to convert this AC into DC, where you have to use in between a commutator and brush. Okay, now this is a kind of generation, or it's a generator where you have to convert your mechanical signal into a electrical signal, right? So ultimately there is a rotation which is coming from the external world, or from the prime movers, and from that mechanical energy, from this mechanical movement, now this particular terminology will convert all mechanical movement into the electrical. So ultimately at the output side you are going to get your electrical signal. So that's how it is broadly speaking as a generator and alternator. Okay. In our next unit, we are going to learn about the electrical installation. Now, why this electrical installation is very important, because everywhere in our home, in our industry, we can see the electrical circuitry that is, installed under the wall. Now, why? Because of those electrical lines are very high voltage electrical lines. So, by chance, if there is a overflow of current, or some current is flowing outer of on the outer body of the any device, and once any human body is going to touch, it will have, or it will get the shock. So in this condition, to protect the human body, we have to start with the learning of earthing. So there are two types of earthing. One you can provide by using the plate earthing, and or pipe earthing. So same way you can also see whenever there is a earthing system is there, and even there is a fluctuation in the voltage, that means there is a fluctuation in the current. So high value of current is flowing in this particular home appliances, this get damaged. So ultimately from source to home appliances, in between you have to use the circuit breaker. Like in on mode, you can see here there is a flow of constant current, but in off mode, when the current rating is high, ultimately this circuit will break the main circuitry. By that way you can save your home appliances. Now there are different types of wires and cables we are going to understand. You can see a single coded wire, or in a kind of transmission wires you can see here. And the last topic is related with the types of battery, the construction of battery. We need to understand how the lithium ion battery is going to be work, what are the different ratings of the battery, like watt hour, current hour ratings, that we need to understand. Okay. Let's have a regular session. So in our future videos we will see all the topics in detail. Thank you very much.